Hi, welcome to the next video on the unit circle. Now you might be a bit confused because the title of this video says something about a circle, but what you can see on the screen at the moment is a triangle. The reason for that is that we're going to start off with a revision of what we've been doing with triangles so far, and we're going to use that to build into this idea of the unit circle, which is a really handy idea, mathematical idea when we're doing trigonometry. And when I first learned about the unit circle, it really blew my mind. So hopefully you'll find it interesting. Okay, so let's just do a little recap at first. So we've looked at some right angle triangles over the past couple of weeks. And we've said, okay, if we've got an angle in the triangle, which we call theta, we call the longest side that's opposite the right angle, the hypotenuse, the side next to or adjacent to the angle that we're interested in, we call the adjacent, and the side opposite, we call the opposite. And we said, and I think you all were very familiar with this, that the sine of theta is the length of the opposite side over the length of the hypotenuse. The cosine of theta is the adjacent side length over the hypotenuse length, and the tan or the tangent of theta is the opposite over the adjacent. And many of you have a way of remembering that, which is so car toa, with those letters coming from the first letter in each of the parts of the formula. Okay, so we're all pretty up to date with that. What was the other thing we learned about triangles? Well, we all know Pythagoras' theorem, and that says that if you square the adjacent and the opposite sides, add them together, that's going to be equal to the hypotenuse squared. Okay, so we're all happy with that. I just want to throw a scenario out there. I want to just say, what if we said that the hypotenuse had a length of 1? Okay, well, we've still got our angle theta here. And I'm going to call this adjacent side here x, and this opposite side here y. They're two nice letters for unknown sides. There's something also nice here in that if we can imagine that this was on an axis, x is the distance across and y is the distance up. So x and y are kind of nice. Well, let's look at our trigonometric ratios. The sine of theta is going to be the opposite over the hypotenuse. I'll write this out, which is y over 1. Now, if I think about that, y over 1 is just y. So really, this tells us that y is equal to the sine of theta. Okay, let's do the cosine. The cosine of theta is the adjacent over the hypotenuse. And in this case, that's going to be x over 1. Well, same thing again. X over 1 is just x. So x has to equal the cosine of theta. And no surprises for guessing what I'm going to do next. I'm going to say that the tan of theta is opposite over adjacent, which will be y over x. Well, we know that y is the sine of theta and x is the cosine of theta. So another way of writing that is sine theta over cosine theta. Okay, well, that's kind of interesting. We can say one more thing using Pythagoras' theorem, which is that x squared plus y squared has to equal 1 squared. And if we know that x is cos theta, cos theta squared plus sine theta squared equals 1. And another way of writing this, often if we're squaring a cosine function, we bring the squared down onto the cosine, and we write it as cos squared theta plus sine squared theta equals 1. Well, that's kind of interesting as well. This is saying that in this particular triangle, if we square the cosine of theta and add it to the square of the sine of theta, we always get out to 1. So that's kind of nice. It also tells us that y is just the sine of theta and x is just the cosine of theta. And if we know those two things, we can also get the tan of theta. Okay, well, big deal, you might be saying. I want you just to keep those things in mind. And in fact, if you haven't been writing this down, I would like you to write down these particular formulas that I'm circling. And I want you to just sketch that little diagram of the triangle because it will become really important in just a moment. Now remember, all of these formulas are nice and simple, and that's because of this. It's because we've said that the hypotenuse was 1, and that makes all of the formulas come out really nicely. So remember that. Okay, now let's have a think about this idea of the unit circle. So what I've drawn here now is a circle on the x and the y axes, and this is our unit circle. So this is the y-axis, this is the x-axis. It's a unit circle. Why is it called a unit circle? Well, remember in primary school when you talked about tens and units? A unit is 1. So we're going to say that this circle has a radius of 1 and it has a center at 0, 0. So the center of this particular circle is at the origin. Now, if the radius of this circle is 1, we know some of the points that it passes through. It passes through 1, 0 over here. It passes through 0, 1 up the top there. Negative 1, 0 over here. And 0, negative 1 down the bottom. Okay, when we look at our unit circle, we can think about it a bit like a racetrack. Okay, and this analogy hopefully will make sense in a moment, but let's imagine this circle was a racetrack, and down here at 1, 0, that's the start of the racetrack. So if you're going to move around the unit circle, you need to start from this point and go in a counterclockwise direction. So anytime we're moving in a positive direction around the unit circle, we always start from here and we move in that counterclockwise direction. So I'm just going to write there that that's a positive direction. So for example, let's say I moved around the unit circle by to this point here, and as I moved around, if I can imagine a line coming out from the origin, I'm going to say that this angle here was 60 degrees. So I would say that I've moved around the unit circle by 60 degrees. Now it's also possible to move around the unit circle backwards. So if I start from here and I go in this direction, I actually say this is the negative direction. So I'm moving backwards around the racetrack. I'm going the wrong way, which is a pretty negative thing to do. It's not very nice. So let's say if I had moved from the start and I had moved in a negative direction by, say, this far, we would say that I had moved, let's say, negative 30 degrees. Okay, so I'm moving in a negative direction. Now it's important to realize that we can actually move further than 90. We don't have to stop here. So for example, if I wanted to move all the way over here, the angle that I would measure would still start from the same spot. So it would start from the start line, and I've moved all the way around. So I've started here and I've moved all the way around the circle. And let's say in this case, I've moved by 160 degrees, okay? Same thing negative. I could have started at the start and gone backwards, and maybe I would end up over here. And again, I've moved that full angle from the start line, and let's say here I've moved negative 110 degrees, okay? Now, this is a bit strange to think about, but you can actually keep moving even further and further and further all the way around to here somewhere. So it's even possible, and my diagram's going to start getting a bit crazy here. If I end up over here, that's perfectly fine. I would just have to draw the arrow going all the way around. I've gone past 180, so let's say that might be 220 degrees. Again, that's positive, okay? Same thing with the negative angles. If I'd moved around and around and around, and my diagram's going to get a little bit crazy now. Around and around and around to here, say. I've gone in a negative direction all the way around. This could be negative 330 degrees, for example. Okay, so that's how we measure angles on the unit circle. Okay, so let's just go back to a blank unit circle, and we're just going to look at this a little bit more carefully. So again, here's my little start point. Let's say I go around the unit circle up to here, and I'm just going to call that angle theta. So I don't really have a particular angle in mind. Let's have a bit of a closer look at this. Let's say, okay, I'm at this point on the unit circle, and I'm going to call that x, y. So when I work out what x and y are, I'm talking about this point on the unit circle. Well, we've gone around by theta, and what we can do here is we can form a nice little right angle triangle by dropping a line down perpendicular to the x-axis from that point. And that's going to be a right angle. And then if I think about the coordinates x and y, well, this is the x-axis, so the width of this triangle along the bottom here is actually equal to x, and the height of this triangle is actually equal to y. Well, that looks familiar, doesn't it? Because we have actually just shown previously, when we were looking at that triangle, that if this triangle exists, if we've got x and y, we can say something about x and y. The important thing to realize here is that the radius of the unit circle is 1. So the hypotenuse up here equals 1. And this is the exact triangle that we were looking at earlier. So for the unit circle, if we have this point, x, y, then x is the cosine of theta, and y is the sine of theta. So we know that already. These are two really, really important relationships to do with the unit circle. So as you move around the unit circle, no matter where you go, you can always work out the x and the y coordinates using cosine theta and sine theta. This is true for all values of theta. So in actual fact, even if we moved all the way around like we were doing before by some huge angle, we'll call that alpha, that angle. So we've moved around by this big angle alpha to get to this point over here. and I'm going to call that AB. Well, the same thing is true. In this case, A equals the cosine of alpha, and B equals the sine of alpha. In this case, though, we know that A is going to be negative, and B is going to be negative as well because of where that point is. But that's okay. The cosine and the sine function can account for that. So, no matter where you are on the unit circle, this rule holds true. Now, we will look at that in a little bit more detail in the next video because I've run out of room here. And we'll also look at the tangent function in particular. Okay, thank you very much for watching.